So, everyone present, thank you for coming by. I'd like to introduce and invite you all to Design Management and Assessment 1. This is the very first installment in a series of workshops where we'll be discussing how to go about their design, how to evaluate, and how to plan, specifically in the future workshops towards engineering, which will be very vital for those who are in capstone now or who will be going through a capstone curriculum, which is pretty, conventional for engineering disciplines. So without further ado, let me go ahead and share my screen. All right. And you all can see these slides, correct?
Yep.
Nice, thank you. I would like to start off by doing a little brief exercise. Before we dig in, I would like you to try to grab a writing instrument or a tablet or something. You can even be mental at this point. But the focus here is to essentially evaluate what your perception of design is before kind of listening to the first two workshops, and then kind of looking at to what you're thinking of design or your perception of design is after the first two workshops. We'll be recapping in the third workshop. So this is, a continuing activity, but we will revisit here on the third workshop. And so what the exercise entails is, and you have to be honest here so that we can do a reflection, and an assessment of your perception for design before answer these three questions. So if you want to just put like a before column and an after column, or even just flip a paper or two papers, how you want to go about it. The first question is, to you, what have been some notable examples of design? And this can be, cars, buildings, boats, computers, components, any type of high level to low level assemblies, essentially. And what is some notable designs? It can be 1, 2, infinite, whatever you can think of. No pressure. The second question is, in your opinion, what is the single most difficult aspect of design? In your definition or language, that could be either a function, it could be a form, an end use, or the specificity of problem mapping. And so definitely question 2 is a little more intensive in terms of reflection, but I'll definitely give more time for this. And then the third question is, name one strategy that you have used to overcome or circumvent a dilemma in school, work, or hobbies, or anything. So with that being said, throughout the presentation, if you have an idea that comes up about this exercise, go ahead and jot it down.
Are these buttons like the option buttons?
And then
Are these the option buttons?
Hello, Chetan.
What's this then?
And we're just doing a brief exercise so you can hear me, Chetan. And then throughout the presentation, you're going to hear a bunch of words to where you may not know them or haven't heard of them before. Don't go rushing to Google to try and answer them or try and look it up, but go ahead and just jot them down. And then we'll go ahead and revisit those words that you may have heard that you want more clarification for. And that way we can, make sure everyone's on the same page. So we'll take a minute or so, just to write down any ideas. And then about that time, I'm going to go ahead and move forward with the presentation. And again, that first question was, to you, what has been some notable examples of design? Again, this can be a car, a building, a boat, computer, components, high-level processes, low-level components. The second question again was, in your own opinion, what is the single most difficult aspect of design? And that can be either through a function, a form, an end use, or even a how to map problems or assess them. And then during a certain overcoming of a dilemma, name that one strategy that you use to overcome an obstacle in your school, work, or hobbies, anything really. And we'll come back to that on workshop 3. Now I'd like to bring forward some examples of design, modern ones at least, and most of these will be very high level systems that encompass a bunch of smaller subsystems, so don't fret. We're going to get to the nitty gritty in a minute. So our first example, this has a resemblance of a lot of monikers and connotations that are popular to certain cultures. This has been an influence from another culture on this iconic design. This is a Nissan Skyline R35 GTR that was conceptualized by an Italian design firm called Pininfarina. And they do a lot of design work that does a lot of concepts for already established or legacy products that exist in the market. So you've probably seen this before, but this is an example of design, and obviously the most notorious or notable. Next example would be, say, a nuclear fusion reactor. There is a bunch of physics and science that goes into these, and essentially the purpose of these are to generate clean, sustainable energy at a relatively low cost, such as all forms of renewable energy generation. But however, there is a lot of engineering and physics that is deeply rooted into nuclear fusion reactors. My final example of a modern one is more of a concept still, is the Beluga Airbus. It is essentially a double-decker either cargo transport or personnel transport airplane, and it is essentially like inspired by a shape of a beluga whale, as you can tell. And this is a form of design that encompasses so many areas of physics, nature, science, the whole spectrum. And this is just some of the notable examples that we are seeing in modern history today. And some older examples that we've gone through in history is like the infrastructure feat of the Hoover Dam. And this is a great thing because it has dual purpose. It keeps water a certain height while allocating that water for use for reservoirs or for extra supply, and at the same time to generate power for the local community. Great feat here, and that's also highly publicized and very infamous throughout our literature and textbooks. Another example is Leonardo da Vinci and his 2 conceptual flying machines. He had a winged machine that represented a bat because he mimicked the shape to resemble a form that would be constructed and easily to be used by humans for flying or hang gliding specifically. And he also developed a Archimedes screw helicopter, which tried to leverage ground effect and the shift or the pressure differential to lift the device. Another example is the Johannes Gutenberg printing press. This is also kind of archaic in terms of our times now because of laser printers. However, this was the first form of copy and paste. Really think about it. And this was essentially a machine that lined up led into certain phrases and words and headers, and that was inked and then printed onto a piece of paper. Another example of design is the first battery, which was actually a voltaic pile, consisted of zinc and silver, and it used a electrolyte bridge between them, such as brine and other sources or other salts rather, to create a electrolyte bridge between the two dissimilar metals, and this created an electric potential. So those are some very dated examples of design and innovation. And so I want to kind of put us into a mindset of what it means to design in the modern day and age. But for forward thinking to occur, there has to be some psychological intuition of systems and the symbiotic relationship between varying bodies. And so I'm sounding very abstract and not traditional because I want you all to conceive what design objectively translates for you as an individual. design has a bunch of meanings and perceptions. I want you to stay as neutral as possible when I give out the next few sentences or bullets on this PowerPoint. It is given that the purpose of design is to solve problems, but what about the underlying steps that have to occur for realization, right? For the first thing, obviously, is that for non-trivial problems, design will always be nonlinear. There will never be a singular path for an objective, target, or dependency. And this is true throughout even, I would say, quote unquote, solved problems that are approximated as linear. For every designer, they require vision. Essentially, the ability to perceive, create, conjure, and identify, and sometimes from nothing, but most of the times from a representation of an object or an abstraction or perception of other solutions around the world. And for every design decision, there must be an allocation to accept what is changed or what cannot be changed. Equivalently, this is known as the trade-off or the compromise that every design must be made for a decision. And the final bullet here is to complete any project, must be executed with the intent of completion. Otherwise, design ceases to push humanity forward. And if to just get technical for a second, from Merriam-Webster, design is to create, fashion, execute, or construct according to plan. And so what this is essentially in an abstract kind of point of view is that design is the silent instigator that redefines possibilities within the broad spectrum of humanly available tools. Simply, design is concerned with how things work, how they are controlled, and the nature of that interaction between animate, aka people, and the inanimate or technology. And one of the final ones is for design, or we're moving forward actually, is that there are 4 essential kind of scopes, I would say, in terms of approaching a design. And how that actually is approached is through an interaction, an industrial design, or an experience design, or a more human-centered design. And these are 4 really big areas of design topology at the moment. You've all probably been aware of this, but just to give you some background, essentially interaction design is focused on how people interact with technology. The goal is to enhance people's understanding of what can be done, what is happening, and what has just occurred. It leverages a mixture of psychology, art, emotion, and design. And there you have interaction design has its own fundamental principles. What this entails is the emphasis to have understanding and usability. Designers produce pleasurable experiences typically. Discoverability, which is a cognitive decomposition of usability. Again, if you are confused on any of these words, just go ahead and jot them down so we can talk about them later. And other concepts include such thing as like object affordances, or what the object is telling you, which is called a signifier, and what you interpret that signal to be. We have object constraints or product constraints, guideline constraints. We also have mappings, feedback. We also have a conceptual model, which is all fundamental aspects of a interaction design. Going down into industrial is technically, by definition, a professional service of creating and developing concepts and specification that optimize the function, value, and appearance of projects and systems for the mutual benefit of both user and manufacturer. It typically is meant to emphasize form and material by balancing costs. The next topic is experience design. And what that is a practice of designing products, processes, services, events, and environments with a focus placed on the quality and enjoyment of the total experience. And so the primary principle of experience designs is to emphasize the emotional impact that is brought on to the end user or the customer or even just for their private interest. And last but not least, human-centered design, which essentially is a philosophy that takes the human's needs, capabilities, and behaviors and prioritizes it as the frontmost constraint for design, given any task, objective, or dependency. And for this to be really successful, human-centered design needs to have a good understanding of psychology, and as well as good communication between human and technology. So very broad spectrums, but the core thing between all of these design scopes is that it's human-based. It's plain and simple. And so, so the challenge of putting all these designs together is, ooh, I skipped one. Here we are. So all these designs can kind of get askew because everyone has this idea, everyone thinks they're, the most amazing thing, or, God's creation, of which we all are, but, they think they're kind of classed. But we have these governing bodies such as the American Society of Mechanical Engineers. We have the American Institute of Graphic Arts, Industrial Design Society of Americas, Society of Automotive Engineers International, and as well as the National Renewable Energy Laboratory. And all of these governing bodies technically publish or contribute towards papers, presentations, editorials, technical reports, and articles that are meant for the betterment of society and the welfare of it. So these government bodies basically represent the ethical construct and the moral construct for these engineers to go forward with good engineering practices. Again, for those, and again, the opposite or anti to that is, bad intentions, which is, we can go far and few on that, but I would like to stay focused on good design. So the challenge that presents itself is that what have we gone through together? And design is multifaceted. It's a multi-problem, nonlinear, and is typically motivated by the willingness to improve or create. In short, we've learned about the intricacies of design and how it's spatially compartmentalized, organized, and how the biggest hurdle is how do we have multidisciplined individuals coherently cooperate to achieve a goal. The biggest design challenge is that it requires a great management team and the tools to keep a project on track. It must find or strike the balance between logic and creativity. It must strike a balance between rationalism and realism, and intuition and confidence. Those are dual dichotomies because one needs the other, or one can work without the other in a sense, but can also be detrimental or very beneficial. It has a lot to do with the person in control. And the origin for that is for us to fill these kind of challenges is because to design is to designate. The rational model is very objective intensive. It relies on parameters, quantifications, qualifications, and a very structured framework to go about a system or throughout a process to achieve an end goal. It can be assumed that typically the rational model fits an engineer's or equivalent, while the action-centric model, which is typically creative refinement, is more geared and fitted towards artists or traditional designers. And this is the first mistake. Designers, whether fashion, engineering, graphic, or web, or any of that, I guess conjunction between all of them, is that they should not bound themselves to the definitions that have been laid down from previous generations. Modern design requires the symbiotic relationship between all these facets to achieve a singular goal, and to kind of remain on this line that has been founded is great for a lot of redundant processes or legacy processes, but for truly innovation, it must take into account a wider spectrum to achieve a more desirable end goal. And that's why we have a specialization for everything now. And it's not to say that traditional processes shouldn't be needed, but for any project or design, There will never be a straightforward or nonlinear approach to solve a problem. True designers leverage every available aspect to guide their designs. And this can be from philosophies or models. And what they are is to interpret goals as a discretized sequence of events that must be executed in a very capitalistic perception. And it must account for various factors. Those factors will go more in depth on in a future workshop. I don't want to overload your brain because we still have about 20 more slides to go through. And I need your attention for another half hour. So the next.
So apparently I'm the host now, and I'm supposed to be leading graphic design, but not graphic design, this design
He
workshop.
just yeeted out of here, man.
Okay.
Did you disconnect?
So let me see here. Well, what do you guys like about cars? All right, let's give you access back.
Wow.
David.
Oh, he's host now. Okay, I don't have to worry about that. I got to scat in like 5 minutes.
It's like you just ran out of the classroom, man.
Yeah, I totally bailed on my own lesson. Now it's screwed up. Oh wow. I moved my iPad and it just shut off my computer.
Was that by design?
It was an attention getter this whole time. Keep you guys awake.
All right. Well,
All right, James.
okay.
I will see you later.
I'm gonna stick around till 4 o'clock, and then I gotta get back to physics homework.
Roger.
Oh yeah,
All right.
same.
All right. So without further ado. So, as I was saying, processes. This isn't just in the satirical form or the rhetorical way where we, do X, Y, and Z and follow a certain order. But we have to understand this at a very neurochemical and very psychological point of view, because without that understanding, we can't make rational decisions, or at least subjectively rational decisions, without having this understanding of how the human brain kind of processes this information. And essentially what I'm going to do is give a brief introduction to tangible tools to help with the overall design process. You may feel overwhelmed or maybe a review, but do not fret. We will cover the material again in depth in the future workshops. This is to only instill, and we will later then reinforce those concepts spoken or discussed today. And so this table here in front of us is basically a broken down system of how the subconscious, your id and ego kind of handle things. And then you have your superego or your conscious, kind of where a lot of the kind of bandwidth that your brain consumes to get things done. And so the distinction here is that the understanding of neurochemical and psychological relationships is heavily founded on the cognitive systems embedded in humans. So designers typically exploit those cognition systems to use a feed-forward process, which is like, for example, an affordance or an aesthetic appeal, while simultaneously receiving feedback. And this happens in like a scale that I don't even want to misinform you guys about. And basically this table resembles a subjective and kind of representation of what the respective features are for your conscious and subconscious. And so from the table, you can see that your intellect or your learned habits are, fast, automatic, there are multiple, and it's controlled, highly controlled. Whereas your conscious, which is what we are using in our brain at a day-to-day basis that we recognize, is very slow, it's controlled, very limited resources, and it's only invoked for novel situations, aka response to life, which is survival tactics or coping mechanism. And so there's a bunch of innate things that we need to understand about humans. And very first off, there are levels of processing, and at those levels of processing, humans have to decide, and it's an innate feature for humans. Decisions are a finite amount of steps, indirected choices. And to conceive, people and designers must process at either level, either conscious or subconscious, of their cognition systems. And the most basic level of processing for humans is the visceral. This is essentially where the survival reflexes, the compensation mechanisms, deflection mechanisms, or immediate response to the environment is what these visceral responses or cognition systems represent. And is a method of doing this in design is using, say, like I said, aesthetic sensibilities or some sort of feedback that gets you to say, wow, look at that, in a sense. That's a visceral response. The next level is behavioral. And essentially behavioral is the learning of patterns and the resulting repeated actions that you commit to from those patterns. It's essentially a sense of relief. It is obtained if the conscious thinking that accompanied, or that the conscious thinking that accomplished an expectation completes said expectation through that action. That sense of relief is then endowed on the human brain to say, I will release X amount of dopamine, or I will release this amount of serotonin, or I may release this amount of cortisol, right? And examples are lifting a glass to drink while speaking with friends, or your torso tensing while running a red light, while flooring the accelerator. For full disclosure, I do not condone running red lights, but we're not perfect. The next step is that this is where the conscious comes in, and it's known as the reflective level of processing. It is very slow and deep. It usually follows an event or succeeds one, and through the evaluation of thorough analysis, a controlled step of our cognition system assigns a cause and it assigns a prediction. And so it tries to, what we call it as rationalizing. And these three processes of levels interact at a very quick instant. It's very indistinguishable unless you're really paying attention. And then at that point, your reflective level of processing is consuming your visceral and behavioral. For all these three levels to work, however, it is used to determine an emotional and cognitive state within a person. And a highly reflective cognition can trigger lower level emotions. Say when I think about my friends, I miss them, I want to see them, or man, we should talk some more. Those are some low level emotions and actions. Another example is having lower level emotions trigger highly reflective cognition, to where you would see, say, like a typical leaf floating in the wind, and that kind of inspires you to think about how you were going about designing a side pod, or how you would go about designing a wind turbine, and etc. And through these 7 stages of action, which you can see here in the picture, is to plan, specify, and perform, which comes from a goal, and that is put into the world. And then from the world, we receive or perceive, interpret, and compare with other examples. And what this does is the visceral actions are noted to perceive and perform, or which is the immediate response, as I discussed before. Behavioral actions tend to interpret and specify expectations. Meanwhile, reflective levels of processing and actions plan and goal sets while comparing the expectations to reality. And so we had previously touched on the rationalization that humans and designers come to when making the decision. Now we're coming to the realization of whether or not that idea can come to fruition, or whether that idea is a good service or process, etc. So there's a lot of neurochemical things, psychological things that has to be evaluated, and we do it at a very quick instant. And now if we go forward into the actual design process, it's broken down into a kind of this like feed forward and feedback system, or a loop, where it typically has to promote the outcome of a result or a product. This is a standard engineering diagram. We have the 6 steps in the boxes with arrows pointing to them, and then are following a waterfall relationship. And then we have feedback arrows going back to certain steps to help you with refining and optimizing along the process. And so a brief introduction to the nomenclature we're using is that there's an identification step, or which is also known as chartering, which is essentially the recognition of a problem, which includes upstream or downstream fluctuations or constraints or relationships. And this is usually done through like a SWOT, SMART, or equivalent type of tool. Definition is what is the problem we're trying to solve? You know, how do we know it's the right or correct problem to solve? And then there's objective data, which we use to make those definitions and find a rationalization for them. So the next step would be synthesis, and that synthesis step is essentially the ideation, the selection, and implementation, where a lot of the time is spent for design. Analysis and optimization are actually quite less than synthesis. And we'll be going more in depth about that in the future workshop. Analysis and operation, that is essentially to test, record, and re-improve or reconfigure configurations or appearances. Evaluation is essentially you gain a conclusion from the comparison between expectations models and prototypes. And for the presentation, obviously this is the proposal, but this is just essentially a accumulation of all the previous steps, and you're ready to present the results or a proposal for a bid to gain a contract. And so this is has been very refined over the years, and that's due to the fact of a capitalistic society. And so design, I guess in a few sentences, is that it's an iterative process with many varying interactive phases. It may consist of various factors, considerations, compromises, or constraints. You can leverage existing frameworks, and processes include, but are not limited to, design thinking, agile, and systems thinking. Again, these are very Western civilization definitions, and this is what humans have defined in terms of private and public interest to move forward with putting out a product and how they go about evaluating that. Again, this is a very, I guess, quantitative and qualitative method. And they're also very non-conventional methods that are still very appropriate. Again, it depends on the scale, and we'll go more in depth on that about scale and how to go about with what tools to use for certain projects and scopes. And yeah, so usually we have a design because we have a result from customer needs. There's a need, and that's why we are, as engineers, designers, are being contacted or contracted to do these certain and accomplished tasks. And so the three methodologies that I introduced briefly is that there's design thinking. And design thinking is essentially to apply critical and creative thinking to understand, visualize, and describe complex, ill-defined problems, and then develop those approaches to solve, while focus is primarily on the problem and the product. The model does use customer feedback for solving ill-defined structured problems, which could be a pitfall because you're essentially using the customer's perception of a problem to define what your end goal is. You kind of want to stay away from that. You want to be able to interpret independently. Agile, which is also another design methodology. It is a method for breaking tasks into small increments with minimal planning, and they do not involve long-term planning. So this is, again, the short-term or agile, as you would say, and this is like a confined method to achieve a result or an outcome for a product. The iterations are short time frames. You move at weeks instead of months, and that typically lasts from 1 to 4 weeks for the scales of those iterations. And the models, this model of Agile relies heavily on customers being part of the team so that changing requirements can be adapted to. Systems, which is essentially a systems level thinking, and that methodology involves viewing problems as parts of an overall system rather than reacting to a specific part, outcome, or event, and potentially contributing to further development of unintended consequences. It's best for complex problems that have multitudes of systems like aerospace, naval, transportation, mobility. All of those require extensive insight. And to go ahead and kind of introduce the tools that are available to you as a designer to start kind of planning and understanding the project and what kind of scope or methodology do you need to use, you can perform a SWOT analysis. And essentially, as an overview, it is basically a tool that can be retrospectively leveraged at any point in the design process. It's not a one-time thing. The purpose is to evaluate internal or external, the strengths and weaknesses of opportunities and threats presented for your company or against it. And SWOT is a powerful tool, but it can introduce subjective information for decision making, such as defining really weak goals or having non-quantitative or non-qualitative values for your goals, or not being able to find a way to measure them, which leads me into my next analysis tool, which is SMART. SMART is a specific, measurable, attainable, realistic, and time-bound tool. And what that entails is that it develops your Gantt chart or your timetable for understanding when a certain task or objective or dependency will begin and end. And from there, you can extrapolate expectations for when you need to project scheduling, or if you need to crash a schedule. Again, we'll go more in depth on those kind of topics later. But as an overview, it is a Gantt chart is essentially a visual representation of an estimated project scheduling. It should be updated at the schedule of the designer or the team's discretion based on intangible and tangible strengths, weaknesses, and threats. Opportunities is typically neglected unless the project is to be research and development intensive. But for kind of like the nonlinear but non-research intensive projects, SMART does not include opportunities. And again, like I said, it should be visited multiple times, and you should start this process as early and thoroughly as possible. This way you don't run into downstream errors. And so to go over the acronym real quick, S represents the specificity or the quality of detail that you assign to an object, task, or dependency. M represents quantitatively and assesses completion of tasks, objectives, tasks, or dependencies. A typically represents the work needed to complete objectives, tasks, and dependencies. And then R is that measure of A to see whatever is attainable, can we actually do it? And it's the subjective or extrinsic needs or intrinsic experience or the capabilities that are provided to you from your team or team members that allows you to attain the tasks that you're measuring and specifying. T will just represent the time bound you give yourself. And again, this time bound value is given from a subjective or a very objective point of view. It depends on the scale, scope, or the scope, project, and scale of the project. So definitely keep an eye on time bound. The next tool I would like to introduce to you is the double diamond model. And what this is essentially your freedoms within the synthesis step, which is stage 3 within the typical design process. And so what this diamond model presents to you is an allocation of time to where you're able to purge or diverge from your initial idea or concept or problem statement. And then once you get to a point where you've exhausted all possibilities or all ideations, you then converge to define whether or not those possibilities or ideas or understandings are feasible. And then once that's been defined, you then expand one more time because you've now defined your user insights. And you expand to look at your possibilities of prototypes, how you can make it, you can have a prototype that's made from paper, or you can have a prototype made from cardboard, or a full working 3D model prototype in simulation or virtually. You can actually have a physical prototype, which also helps to push things forward. But then again, prototypes can come in every scale and in every form. It's a matter of presenting it and achieving what your end goal was and whether or not you hit it or not. And you then test those prototypes through a convergence process to narrow out your selections between systems or components or different assemblies. And you then go to that user-centered solution, which you then push out towards analysis and optimization, which then goes back to the iterative process of design. So You will see a lot of loops. Don't be discouraged by it because you will arrive at a solution. It just takes time. And I would like to bring up another kind of on the edge of what it means to break down the requirements for design or product. You can see in the top left that we start with a requirements matrix, and that's what's given to us by the customer or stated what is wanted. And then when those customer requirements then define our design requirements, those design requirements define the engineering design needs. And then those engineering design needs become the engineering design requirements for the product itself and its characteristic handling. And then those needs are then represented as product characteristics, objectives, which are then, so you can see the trend here. One feeds the other. And throughout this relationship, in essentially 5 steps, as you can see, you should be able to go from ideation to production. It looks simple here, but those lists and the number of rows and columns could be 10, could be 20, it could be 30 long. It's all dependent on how much you want, how much time you have, the cost that's available to you, and the priority for those certain concepts or goals or features. So it's this will get very, very messy in a capstone, so be wary of it. What's going on? Okay, cool. So as some rule of thumbs that I've learned over my lifetime so far, and I wanted to share them with you all as when you go about with your designs, some rule of thumbs that I wanted to kind of share with you all so that it can maybe help you guide you in your future design processes in the event that you're unsure or you're having a really difficult time. These basics can help you progress through those. And the first one, and I don't want to cause any anxiety, is that the day a product development process starts, it is already behind schedule and above budget. Keeping that thinking of mind, obviously you must be conservative. So that's a well-known quote from a designer, Don Norman. Another typical rule of thumb is the triple constraint. So the triple constraint, if you can imagine a triangle, at any point of the triangle, you put time. At the other point, you put cost. And at the third point, you put task or priority. Essentially, the triple constraint represents that you can only pick 2 of those, and you have a working design process, and one will always go to shit. So if you choose to have priority or tasks and time allotted to be your main objectives, you're going to have an uprising in costs. And conversely, if you choose time and cost to be your main objectives in a project, just know that priorities and tasks may get dropped or fell behind. It's one of those really, I guess, intangible tools that help to guide you through your decision making. Another rule is called the rule of pi. The rule of pi states that whether it is cost related or time related, multiply your expected due date or cost projection by pi. So and this is to obtain a more realistic timeline for deliverable. So for example, if you think a project will take 3 weeks, you multiply it by pi, you'll get 9 to 10 weeks for that actual project timeline. So you think you can accomplish something in 3 weeks, multiply it by pi and see if it's still a realistic thing for you to do. Another thing, and this is when you become a more career, you begin your career rather, is that this is very, you always hear the indoctrination that the customer may be right or is always right. But I would like to add to that from one of my mentors back home was that the customer is always right, but they are not necessarily correct. So the customer can have the last say in a certain position or discussion or argument or presenting their rebuttals. And you always have to accept what they say as being right, but you don't have to accept them as being correct. It's taking their feedback as a grain of salt and allowing it to push you further or help to refine. Another quote, or a rule of thumb rather, is that designs saves lives, period. Good engineering design anyways. And so it's fundamental, especially for humans, because of all the tools that are available. And we need to make sure that we design to these things and stringent guidelines so that when we go about into society, we can make a better and lasting impact. This last few segment is basically about Arthur King, or W.J. King rather, and he wrote this, like, I guess, commandment for engineering. And he wrote, like, I think 10 or 15 rules that you should follow. And they're not necessarily spoken or written rules. These are like the unwritten rules or the unspoken qualms for engineering, and specifically for systems. And so King's first unwritten law was that when you're out there in the your career field, you, however menial and trivial your early assignments may appear, you give them your best efforts. If you do not make a good first showing on your present job, you are not likely to be given an opportunity to try something of your liking. If given the opportunity, complete it to the best of your ability. And he wrote a few more. Another law that I like that he wrote is the sixth unwritten law, and it goes, avoid the very appearance of vacillation. One of the greatest indictments of an engineer is to say his opinion at any time depends merely upon the last man with whom he spoke to. And so refrain from stating an opinion or promoting an undertaking until you have had reasonable opportunity to obtain and study the facts. That's just a good train of thought going forward. Personally, that rule sinks really deep because I definitely violated that law, that unwritten law, and it put me in a bunch of hot water. So that one is very particular to me. McClinton's third unwritten law, and this is a system engineer who wrote another set of commandments specifically for systems engineering. McClinton stated that there's no such thing as a free lunch. Never become so enamored with a design decision that you forget the downside of the decision. Engineering is the art of compromise. And so if you can understand those trade-offs, like I mentioned earlier, it will help you 30-folds when you go out there to make design decisions, and especially practicing the technicalities and repeating those will put you into a good engineering practice. I wanted to cap off our session with a video, and I wonder if it'll play.
Build custom industrial machines in days. Design your.
We're in Copenhagen, Denmark, and behind me is Copenhill. It's a waste-to-energy plant which turns the city's rubbish into heat and power. But one of the most remarkable things about it is that there's a dry ski slope on the roof. It's been designed by Danish architects Bjarke Ingels Group, or BIG, and the whole point is to create a dual use for the building and to make one of the least desirable places in the city, the place your rubbish goes, into somewhere people actually want to visit.
My name is Bjarke Ingels. I'm the founder and creative director of Bjarke Ingels Group, or BIG. And we are standing in Copenhagen on this human-made mountain where you can hike, you can ski. What's even more unique about Copenhill is that it's the cleanest waste-to-energy power plant in the world. There are no toxins coming out of the chimney, just some steam. In this case, the innovation is the clean technology. So that meant that we could completely reimagine what does a power plant mean.
My name is Jacob Simonsen. I'm the CEO of ARC. Here we produce so much energy that we are able to make 19 Olympic-sized swimming pools boil from 0 to 100 degrees every day. We treat waste from Copenhagen and 4 other municipalities in the greater Copenhagen area. We service about 6 called the bunker. From the bunker, it is feeded into the furnaces. The furnaces will burn. When it burns, it will heat up the district heating water. And the other part of the water goes into steam, and that steam runs a turbine. The last piece of the process is the scrubbers, the big towers you see out here. It is actually an acidic shower with calcium to take out the environmental hazardous products before we emit clean air and water vapor to the environment.
In the city, you know, you're not supposed to walk on the grass. You have to wait for the green light. You can't climb the facades of the buildings. On this building, all the things that you're normally not supposed to do, you're actually more than welcome to do. At the tallest moment, almost 100 meters, there is the tallest climbing wall in the world. Here you actually have an elevator that takes you from the foot of the mountain to the peak of the mountain. You look out over the city as you rise. You can look into this cathedral of waste to energy. All along the perimeter, you have more than 200 trees. All the species have been chosen so they can endure the climate almost 100 meters up in the air. So it's this kind of natural meadow. It feels like a little slice of Switzerland in the middle of Copenhagen.
Copenhagen is a great example of Bjarke Ingels' concept of hedonistic sustainability. This idea that just because something's rooted in sustainability doesn't mean it can't also be fun. And you don't have to sacrifice comfort or enjoyment to do things that are good for the planet.
It doesn't have to be a dirty, polluting, big, ugly box that casts shadows on the neighbors and blocks the views. The most sort of exciting and dramatic part in the city is now sitting on a bedrock of a power plant.
And yeah, so thank you all for listening in and staying around for this first workshop. I will be posting the questions that I asked in the beginning if you want to catch up with it, so that by the third workshop we can
The all-new Kia K5 is
with a workshop or with the recap of what we discussed earlier today, and that way you can all stay on track. But without further ado, I have to run to work really quick. I hope you all have a great day. Have a great weekend. I'll see y'all later.
Thank you. That was a great presentation.
No problem. Anytime, guys. I'll see you in the next one.
Like a